Hi there, welcome back to this channel. In this video, I'm going to take you through chain rule problems. I have a problem for us to solve, right? So find the z on the x for z is equal to x ln xy plus yq, right? Where y is equal to cosine of the expression x squared plus 1. This is a partial derivative problem, right? Yes. So we have a function of x and y, and you've been asked to find the z on the dx, right? But the y itself, not knowing, has also x within it. You get it? So if this is the first time being on this channel, kindly subscribe to support and please watch this video to the end. So let's see how you solve this problem. So now, whenever you are being given a chain rule problem or any differential, what you're going to do is you look out for what have I been asked to differentiate with respect to, or what is the entire goal of what my derivative. So we are finding the z on what the x, right? Meaning we are differentiating this function z with respect to what x. To do that, whatever being y here, right, becomes what a constant if it had been a partial derivative, right? But ask yourself, the y here is not just y, it's also another function of x somewhere. So meaning that we cannot do away with y despite the fact that we are differentiating with respect to what x, right? For that reason, we are going to differentiate with respect to x, alright, and we will also differentiate with respect to what y, because y has also what x in it, right? Because y has x in it. And before you can access the x in y, you need to differentiate y so that the door will be open for what y to be accessed. Then you differentiate the y with respect to x. So let's see how we can do this. So as I said, we are going to differentiate with respect to x. So directly we are going to differentiate this function with respect to x. So differentiating with respect to x, realize that I have a linear function attached to a natural log function here, which is a logarithmic function. So there are two different types of functions. So what I'm going to do is I use the product rule, right? So differentiating x, I'm getting 1 and maintaining my logarithmic parts, okay, plus maintaining x and differentiating the logarithmic part, I'm getting, when I differentiate here with respect to x, I'll get y over xy, okay, plus, so this is all for differentiating with respect to x, right? So as I said, once you differentiate this with respect to x, you would have to differentiate with respect to y to open the door for us to access the x also within here. Is that not it? Yeah, so plus, we will differentiate this whole expression with respect to y. So with respect to y, x here is a constant. We only have to solve what is inside here, and that will give us what? That will give us, when you differentiate what is inside here, we are, with respect to y, you are going to get x over xy multiplying x, where this x is the one out here, okay, plus my y cube is simply 3y squared, right? So once I do this, then as I said, once you open up the door for the y, you have to differentiate y here so that you can what? So you multiply by what? The derivative of what? The y here on the x, right? So when I differentiate this with respect to x, I will differentiate my inner function and I'm going to get 2x, right? Multiplying the derivative of the entire function, that would be negative sine x squared plus 1, like that. So now, obviously, the z on the x is set equal to the z on the x times dy, sorry, the z on dy, multiplying dy on the x, right? So now, to get the z on the x is either by what, the z on the x multiply by what. So let me change this one, multiplication, okay, this addition. Yeah, so the z on the x or the z on the y times the y on the x, and this gives us our partial our derivative here, our differential here. So now let's simplify what I have here further. So my z on the x here is simply equal to 1 by ln x. You're going to get ln xy. Here, x will cancel this x, right? And I have y cancelling y, and I'm getting 1, okay? So plus 1. So once I get plus 1, then I simply come to this side plus. For this side, x will cancel this, and I'll have x over y. X over y. Then plus what? 3y squared. So this whole expression is being multiplied by what? Negative 2x sine of the expression x squared plus 1. So this is what we've reached. And you know, at this point, the question asks us to us differentiate x with respect to differentiate z with respect to x. So at the end of your differentiation process, you have to make sure that the only variable you are seeing is the derivative, if the function at the denominator here, because the question said differentiate with respect to what? X, right? So we're expecting a function of what? X at the long run. So now let's see. We have to replace y wherever we see what y with the content of y, which is cosine of what? X squared plus 1. So wherever I see a y, my y, I just put that. So z on the x is equal to, I'll have natural log of x multiplying the y, which is cosine of what? X squared plus 1 plus my x over cosine of x squared plus 1 here plus 3 open brackets cosine of x squared plus 1 all squared multiplying negative 2x sine x squared plus 1, right? So there is a substitution we've made. So is there any possible simplification anywhere? If you have, you can go ahead. If it's going to be a cumbersome process, then you can also just stick to maintaining it this way, right? So let's see. This can be finalized as natural log of x cosine of x squared plus 1 here. Then now let's see. Here will be plus. I'm having this multiplying everything here. So minus 2. Remember, it is negative 2x. I'm multiplying by this expression. Okay. So minus 2x squared sine x squared plus 1 all over cosine of x squared plus 1. Then here, I'll come here. I'll have plus. So minus 6x sine x squared plus 1 multiplying cosine of x squared plus 1 all squared. So this gives me my derivative with respect to what? X when I am differentiating my z. Thank you for being with me in this video. Kindly subscribe to support. Don't forget to like and share.